xt and yt. Consider two signals xt and yt. Both are periodic with period t naught. And if we write the Fourier series representation t naught, that is ak, and Fourier series bk. Now if we consider the signal xt into yt, will it be periodic with period t naught? Will it be periodic with period t naught? If xt and
Yes,
yt are periodic, it is always periodic with period t naught, but it is not necessary that its fundamental period can be less than that also. Is it possible? For example, if you consider cos, let's say cos 2 pi t multiply with that signal, what is the fundamental period? What is the fundamental period of cos square 2 pi t? Half. What is the fundamental period of cos 2 pi t?
1.
Sorry?
1.
1. What is the fundamental period of cos square 2 pi t? What? Is it cos square 2 pi t is 1 plus cos 4 pi t by 2, isn't it? It is half. So it is half of that. So fundamental frequency may change. It can be lower than the lower than t naught also, but it is always periodic with period t naught. We are not bothered about the fundamental period. So what I am saying is we can always find a Fourier series representation with respect to t naught. This xt into yt will always be periodic with period t naught. Let me denote it by ck. Then what is the relation between these two? These three. Okay, let me prove that property. This means that this is ak e to the power j k omega naught t, that is equal to xt, and this implies that bk e to the power j k omega naught t yt, isn't it? Now we are trying to find the Fourier series coefficients of xt into yt. And what does this mean? This means that this summation k minus infinity to infinity ck e to the power j k omega naught t, that is equal to xt into yt. Okay. Now let us multiply these two, xt and yt. So this is k minus infinity to infinity ak e to the power j k omega naught t into summation over k bk e to the power j k omega naught t, that is same as, is it this? Ck into e to the power j k omega naught t. Is it?
Yes, sir.
Okay. Now tell me, what is the relation? What is this? Okay, let me expand this summation, this infinite series. Is it a0 plus a1 e to the power j omega naught t plus a2 e to the power j2 omega naught t? Okay, that's an infinite series. This side it is a minus 1 e to the power minus j omega naught t plus, there is a term a minus 2 e to the power minus j2 omega naught t, isn't it? I'm expanding this. Then we have to multiply this with this infinite series. So this is b0 plus b1 e to the power j omega naught t plus b2 e to the power j2 omega naught t plus b minus 1 e to the power minus j omega naught t, b minus 2 e to the power minus j omega naught t. Okay, we have to multiply these two, and that is equal to what? Ck in terms of this. That is equal to Ck C0 plus C1 e to the power j omega naught t, C minus 1 e to the power minus j omega naught t, isn't it? Now tell me, what is the relation between AK, BK, and CK? What is the value of C0? When you multiply these two, you will get this. What is the what is C naught? C naught is the constant term here, isn't it? So you have to multiply these two and find the constant terms. Equate those two. Tell me what is C naught?
A naught, B naught,
Is it A naught, B naught?
plus
The
A minus
summation
1,
of
B naught,
Plus summation A1, B minus 1.
so on.
And here, what?
A minus 1 B1.
A minus 1, B1. A minus 2, B2. Okay, this is an infinite series again. That is C0. What about C1? C1 means here it is e to the power j omega naught t. So multiply these two, find the corresponding terms which are having that first harmonic. Okay. What is that? A0 is multiplied with which one?
B1.
B1,
A0, B1 plus A1,
B0,
B0 plus A2, B1. That sequence will go
B
on like
minus
this.
1,
Sorry. Okay, this
B
is
minus
B
one.
minus
sorry,
1.
B minus 1. And this side? A minus 1, B minus 2. Oh, sorry, B2, B2. Yes?
Yes, sir.
Can we generalize this?
Sir, Ck is equal to summation of A minus M into
Is it,
BK plus.
is it some familiar summation form? But you are saying that Ck is equal to?
Convolution.
It is the convolution. Minus infinity, what? A, M, B, K minus M? Is this? This one?
Yes, sir.
Is it the convolution? Is it the convolution? So can we write this Ck is equal to Bk convolution, sorry, Ak convolution Bk?
Yes, sir.
So that is the multiplication property. So let me write it here. The property is that if xt Fourier series T naught Ak and yt Fourier series with respect to period T naught Bk, and one more thing, it is not necessary that you have to find this Fourier series representation with respect to its fundamental period. If you can find this with respect to any common period, okay? And these are the corresponding. Only thing is that you have to make sure that all the Fourier series, periods with which we are taking the Fourier series coefficients, they should be the same. So xt into yt, we can always find a Fourier series representation with respect to period t naught, and if we denote it by ck, that is ak convolution bk. That is the multiplication property. When you multiply these two signals, it is the convolution in the Fourier domain. Let us consider an example. Okay, so let's this itself is good example. Cos square 2 pi t. First, let us find the Fourier series coefficients of cos square 2 pi t using the convolution property. What are the Fourier series? Cos square 2t is cos square 2 pi t is cos 2 pi t into cos 2 pi t. So what are the Fourier series coefficients of cos 2 pi t? Fourier series coefficients. What is that? What is the fundamental period of this? Isn't it? 1. What are the Fourier series coefficients?
0, half.
You should always remember this sine and cosine signals. What are the Fourier series coefficients? Okay. So only 2 non-zero coefficients. Okay. Now tell me what are the Fourier series coefficients of cos square 2 pi t? So if we sketch it as a signal, this is 0, 1 by 2, 1 by 2. Is it? Cos 2 pi 2. Now what is cos square 2 pi t? Fourier series with respect to t naught with respect to period 1. That is important. When you apply the multiplication property, you have to make sure that you are finding the periods with respect the Fourier series with respect to the same period. With respect to period 1, is it the convolution of this and this? Is it? That is the multiplication property. You are multiplying cos 2 pi t with itself. Then it is the convolution of this. Can you tell me what is the convolution of these two? Let me sketch that values. What is convolution? Flip one of this, slide it from minus infinity to infinity, multiply those two. Tell me, first tell me what is the value at 0? Convolution of these two? Multiply, flip the second sequence, multiply these two. What is that? Flipping, this is an even signal, isn't it? Flipping, you will get the same signal. So when you multiply, so after flipping, you will get something like this, isn't it? Same signal. Multiply these two, then add those. What is that? Is it 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2?
Yes.
What is that? Is it 1 by 2?
Yes, sir.
Then what is 1? 1 means what? This you have to shift it right by 1 and multiply those two. What is the value?
0.
0. And then 2.
1 by 4.
1 by 4. And what about other values? There will not be any overlap if you shift it further, isn't it? Towards right. Is it? You are flipping. What is convolution operation? You are flipping this and shifting it, multiplying those two. If you, this is the point 0, and if you want to find 1, means you have to shift it right by 1. For finding this 2 means you have to make this point at 2, isn't it? Then multiply those two. So can we say that for all other positive values, the convolution of these two will be 0?
Yes, sir.
Yes, sir.
Now what about the negative side? Negative side means for finding the value at -1, you have to shift this left by -1, left by 1, multiply these two, find the sum.
0.
It is
0
0.
for -1 and -2 will be 1 by 4.
-2 will be 1 by 4. Will there be any other non-zero value in the negative side?
No, sir.
No. So these are the Fourier series coefficients. That means cos square 2 pi t, Fourier series with respect to which period? Fourier series with respect to what? With respect to which period? T naught is 1. That is this one, 0. Sorry, this is 1 by 2, 0, 1 by 4, 1 by 4, isn't it? Is it? Now let us try to find this directly using the direct method. cos square 2 pi t. This is 1 plus cos 4 pi t by 2. What are the Fourier series coefficients of cos 4 pi t? What is the fundamental period of that? Cos 4 pi t? What are the Fourier series coefficients with respect to that fundamental period? Cos 4 pi t. 0, half, isn't it? Okay. Now here we have found the Fourier series with respect to period 1. What are the Fourier series coefficients of cos 4 pi t with respect to period 1? What is that property?
Insert 0 between two non-zero variables.
And it is not non-zero coefficients. It is between two, between
Consecutive
all the consecutive Fourier series coefficients of this one. Okay, is it
Yes.
0, 1 by 2, 0, 1 by 2? Because here the period is, these Fourier series coefficients are with respect to period half. Now we are considering Fourier series coefficients of the same signal with respect to double of that. So the operation in the Fourier domain is insert 1, 0. Okay. So are we getting the same result? Cos square 2 pi t is what? 1 plus cos 4 pi t by 2. Fourier series with respect to period 1. What is that? What is this operation adding a constant? First of all, what is this effect? If you divide by 2, Fourier series coefficients are also divided by 2, isn't it? If
Yes.
and what about this? Adding a constant 1 by 2?
It is A0 plus
A0,
constant.
A0 only the average value. A0 denotes the average value of the signal, so the average value will change. Are you getting the same answer?
Yes. Sir.
You'll get the same answer. Okay. So that is the multiplication property of Fourier series. Only thing you have to remember is this is applicable only when you consider the Fourier series coefficients with respect to same period.